All right, my name is Rajeev. I'm the program director for worldwide deployment and systems engineering at IBM Quantum. I will say many of the things I've heard so far probably already stole some of the thunder of what we are looking at from suppliers, but I'll still talk through it. Let me take a few seconds just to kind of walk you through what IBM Quantum does. This is really a stacked view of the various industry segments, if you will, for the quantum computing industry, kind of hardware, control systems and software at the bottom, applications and services. We certainly are what we would call a full stack or an end-to-end provider. There are many others, many other members of QED-C that serve some of the other markets. So, and of course, just highlighted at the bottom there, we focus on superconducting qubit systems. So this is our roadmap that we published a little over a year ago, and we've been kind of marching towards. We updated it in our Quantum Summit about a few weeks ago. Really, we've been, I think, doing a great job just marching through our roadmap over the last few years. We've shown scaling our hardware as well as all the other aspects that go in terms of introducing features into our software stack, algorithms, as well as application services that kind of go along with it to really make these quantum computers useful. Today, though, of course, I'll focus much on kind of the hardware side of it. That's probably most relevant to many of the team members here. So we, as Mark was highlighting, we did demonstrate that we have our 127 qubit system, which hopefully we start to give access to some of our clients by the end of this year. And already started work on our next scale up, right, the 400 plus qubit system. Of course, as we continue to go scale these, many of the things that were already mentioned, and great that everybody kind of has a 1,000 qubit target that they're watching in their roadmap. And certainly we want to look not only at 1,000, but well beyond that. There's certainly certain things that kind of come along with it. Now, I have this for people who are not as familiar with what a superconducting quantum system might look like. But certainly on the left is some of the components that go inside the dilution refrigerator. Of course, the processor at the bottom, and then, cryogenic amplifiers, isolators, cabling, of course, as well as the need for thermalization, and then on the right, what we would call kind of what's controlling it, right? So today it's room temperature electronics, that's digital components, analog components, DACs and ADCs, and signal generators, right? And of course, in the future, well out there with work already started across the industry, how do we start to move some of these control components inside the cryostat as the number of qubits goes to tens of thousands to millions, right? But today we'll kind of focus on these aspects. There's a bunch inside the cryogenic environment and a whole bunch of room temperature. And so as I kind of look at it, right, what are our needs? And as I said, many of these needs have already been mentioned by kind of many of the panelists already, right? Certainly the electrical performance, we have specifications for. I know there was a comment earlier on, well, the specifications aren't that clear, and I'm hoping, we can connect so there is clarity, especially on many of the components that are inside the cryostat on what we need those technical specifications to be. Certainly, the mention of thermalization came up. That's important as well, especially as we start to scale up. We really don't want these fridges to grow at the rate aligning with the number of qubits, right? And of course, another very important piece of it is from a mechanical and size perspective as well, both on the components that are inside the cryostat as well as outside. Stability and reliability, right? Glad there was mention already of kind of manufacturing capability, taking something that's in the R&D stage and scaling that up. That's of course important. As many of you know, we certainly have systems, in our New York data centers, but outside of this area at client locations, and you can imagine these are operating for months and some of them even years at a time. We want to make sure the stability and reliability of some of these components. And certainly looking beyond, right? So we have kind of obviously our tactical needs with volumes that we are working with, but also, as we look to going down our roadmap, and the industry does as well, and these specifications evolve, right? Some we know, some we're probably not as sure of, but as these evolve, would you as a vendor or supplier have a roadmap, have that flexibility to be able to provide those, test those, see if it meets specifications, and then include them in system testing, and then of course the manufacturing capability and the controls that look at both volume as well as turnaround, right? So what can we bring to the table? Certainly from a technical specifications point of view, as I said, I think there are many that we have a good handle on based on our experience and understanding, and others where I think a lot of it will evolve as we learn more and we kind of continue down our road, right? Certainly, in terms of capability, I think we certainly have a good understanding of how qubits work, what kind of specifications are needed to get to the fidelities that we are looking for in our systems. And so a system application test is something we could enable once we've kind of have a chance by suppliers and vendors to be able to look at those components at the temperature, whether it's cryogenic temperature or so on. And we have an understanding that it certainly meets those specifications. And then, hopefully provide that opportunity to the suppliers and vendors as we continue to grow. We see a fairly we have an aggressive roadmap on where we see the industry going, and certainly that translates to higher volumes and broader use. I'm sure that's discussed in many of the other tags within QED-C and elsewhere. And we're hoping that our suppliers going to grow with us. I think that is it. I do have a chart here that just talks about our worldwide presence. I think some of you may know this, but I'll stop here and then you can take the rest in panel discussion, Q&A.
So there's a quick question, you can decline it or answer from one of the people in the chat. They were asking about the noise performance of the new 127 qubit system.
Yeah, no, I'll mention it. I mean, I think honestly, at this point, some of the qubits are showing numbers very similar to what we've had on our Falcon 27 as well as our Hummingbird 65. But we're still kind of working on the system that we're kind of bringing out to clients. So hopefully everybody will get a chance to look at those numbers. We usually have them on our cloud services website. If I'll get a chance, I'll probably be able to post that link. And then when that data gets populated, everybody will get a chance to look at it. But at a high level, 2 qubit gates are in the 1 to 2% range.